Hello and welcome to day 3 of Advent of Code, and the topic for day 3 is binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, which is our puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate two new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying those. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, and we get a list of binary numbers here, considering only the first bit of each number, so the first digit of each line, there are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is also 1. The most common second bit of the numbers in the diagnostic report is 0, so the second bit of the gamma rate is 0. The most common value of the third, fourth, and fifth bit are 1, 1, and 0 respectively, and so the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number 10110 or 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used. So the epsilon rate is then 01001 or 9 in decimal. Multiplying the gamma rate 22 by the epsilon rate 9 produces the power consumption 198. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate, then multiply them together. What is the power consumption of the submarine? And we are supposed to give the answer in decimal, not binary. Alright, so today we're coding in Visual Studio Code again, because I just got tired of Colab and managing all the different files on there. So, slightly different interface today. I have already created a txt file with the example input that we were given in the text, so we can recreate the results where they already told us what the answer is, so we can test our code on that one. And then we also have the official input, which is quite a bit larger, as you can see, and which we will need to use for our final answer. And then finally I have created the notebook file as always. So the first thing we will do is import these binary codes, and let's put them to the side so we can see them. Alright, so as always, let's first create a markdown file and say this is part 1 of the puzzle. Okay, so the first thing we do in part 1, as always, is open the file. And now let's define a function so we can call this with the example file and also the real file without having to hard code it every time. So we open the file in read mode. And read all the lines, and then the lines in this case are the diagnostics, and just to be sure, we strip each line so there's no white space at the end or anything for entry in lines. Okay, and now we are supposed to create two new binary numbers, and these are gamma and epsilon rate. So for these it was explained that we go through all the diagnostic lines, and at each position we check all the lines and count if 1 is more common or 0 is more common. So we will create a loop which goes through one line but at all lines at the same time. For I in range, and then we will do the length of just one of those lines because they are all the same length. Otherwise we couldn't really calculate the most common bit, or it would be a bit more difficult, but they are all the same length. And then we will create a list with all entries at that position. So now we say entry of I for entry in diagnostics. So we go through all diagnostics and take the appropriate bit that we're currently looking at from it. And now we count in this array. Unfortunately, lists have a handy count function. And let's count the zeros. And if it's bigger than half, so length of diagnostics divided by 2. Now it doesn't tell us what it wants us to do if the numbers are equal, so if 0 and 1 both appear the same amount of times, so we will just ignore this case for now and hope it's fine. So if 0 is the more common bit, then, oh no, these are both not 0, but they are both empty strings. So if 0 is the more common bit, then we add it to gamma. This also means that the least common bit will be 1, so we add that one to epsilon. And in the other case, if 1 is more common, we add that one to gamma, and 0 to epsilon. And now let's print gamma and also integer of gamma with base 2. That's how you can convert a string of a binary number into an integer. And let's do the same for epsilon. And then we can also find out the power consumption because it was the product of both of these. So for that, let's copy and multiply. with epsilon. Alright, execute this. This will define the function. And now we can call part 1 of example txt, and it tells us this gamma is 22 and epsilon is 9 and the power consumption is 198 as was written in the text. So the code seems to be working just fine, so now we can just execute the same with the real input. And now gamma is 2849 and epsilon 1046, and the power consumption is 3,549,854. Now I would show you how I insert this in the form as always, but sadly this is a re-recording because the first recording didn't go as planned and the audio is a bit wonky, so I already inserted this, but it's the correct solution. So we did everything right and we can continue with part 2. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. And I will just call them oxygen and CO2 from now on. Both the oxygen and the CO2 are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers, and then consider just the first bit of those numbers. Then, keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers that don't match. If you only have one number left, stop. This is the rating that you're looking for. Otherwise, repeat the process, considering the next bit to the right. The bit criteria depends on what type of rating value you want to find. For the oxygen, determine the most common value, 0 or 1, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1 in the position being considered. To find the CO2, determine the least common value and keep only numbers with that bit, and if they are both equally common, keep values with a 0 in the position being considered. For example, to determine the oxygen using the example diagnostic report from above, start with all 12 numbers and consider only the first bit of each number. There are more 1 bits than 0 bits, so keep only the 7 numbers with a 1 in the first position, and then they list them here. Then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bits, so keep only the 4 numbers with a 0 in the second position. Continue like this for the third, fourth, fifth, and so on position, and after the 5th position there's only 1 number remaining, so we stop, and that is our oxygen rating, which is 23. For the CO2 we do the same, but with the least common value, and we get a 10 in decimal. So then we multiply them. 23 multiplied by 10 is 230, and now we need to do the same for the input diagnostic report. Alright, so let's now work on part 2, and as a first thing I'll just copy what I did at part 1 and just rename this to part 2. I think I created a markdown file. Okay, part 2. Now let's see, we can reuse the reading, that's exactly the same. Let's make some space here. let's first do the oxygen. First we need all of the diagnostics, but these will change. So at first we need the full list, but then as we go on we discard more and more of the original diagnostics. So we should copy that list, so we don't want to delete from the original list. So from copy, import, copy. That's a weird import, but it is what it is. And then we copy the original diagnostics like this. And now, as before, actually I can copy this, we go through the line and we get all entries at that bit, or at this position, but we don't do it of all of them, but only of the remaining entries. Alright, and now we need to update the oxygen diagnostics list. So now we need to remove some of the entries, and for that I want to go through the original list, obviously, and we will keep an entry for entry in oxygen diagnostics, but we will only keep it if a condition is fulfilled. So I actually don't think I need this backslash here. So we only want to do it if this entry at the ith position has the common bit. And I don't want to put the whole expression here, so we will save the common bit beforehand. So this is a 1 if our counting that we previously did so if we count all the ones, and if it's bigger than length of oxygen diagnostics divided by 2, and also if it's equal, because this time we have this information, if it's equal we want to use 1 in this case, and if it's not the most common, then of course we want to use 0. And now we still need the break condition, because we want to stop if we only have 1 entry remaining. So if the length of the oxygen diagnostics is 1, then we break out of this for loop and we don't consider the rest of the bits. Right, so this should give us the oxygen rating. So print or save oxygen rating in this variable, and we still need to convert the one and only entry in the array now to a real number, and then we can print oxygen and the binary number just to compare it to the example, and also the decimal number. At this point we can remove all of that down here, and now we will all of this and do it quite similar for the CO2. So let's change this to CO2. We still want to copy the diagnostics. And now let's change all of the oxygen stuff to CO2. Also, the rating will be the CO2 rating. Right. And now the only thing that we need to change is that we want the least common bit. So now if 1 is the most common one, then we want to use 0 because we want the least common one, so the opposite. And we also want to use 0 if they're both equally as often in there. So we can keep this equal sign there. And in the other case, we of course want to use 1. And I think that should be that for this. Now it's time to try it out, I think. Oh, and also we of course want the, I think it was life support rating, which will be the oxygen rating times the CO2 rating. Alright, process this, and now we can do part 2 of the example. And we have 23 and 10, which will be 230 when multiplied. And that's exactly what was in the text. So that seems to be working. And now we can try it for the input file. So we get 2,783 for the oxygen and 1,353 for the CO2. That means our life support rating will be 3,765,399. And if we check with my previous result, then this is exactly what was the correct answer. So both parts of this puzzle are completed, and they provide 2 gold stars, which means we have a total of 6 gold stars now. As always, I will upload the code to the GitHub, and I hope you enjoyed this slightly late solution to day 3, and I'm excited to see you in day 4 and 5 and 6. Thank you so much for watching. Bye!